Good morning or good afternoon, ladies and gentlemen, depending on when you're joining us from. We have here today one that is a very hot issue and that is being really debated, and we've had a lot of sign-ups for this particular online session. In fact, it's one of the most popular online sessions we've ever had to date. With me here today, I've got four experts for this specific issue, the blockchain. We're going to discuss today the impact of blockchain in the energy industry. Unfortunately, just to let you know, we are having technical difficulties with one of our panelists, so hopefully he will be able to join along the session and we'll hear from him. But with me here today, I have Nasser Saidi from the Clean Energy Business Council, and we will hopefully be able to get him into to give you his speech in this session. Then we have Amira Katab from Dark Matter Energial. And Mark Manzano from Dark Matter. Guys, can you just give us a little wave and tell us where you're joining us from?
Yep. My name is Amira, and we're right now in our offices in Abu Dhabi, United Arab Emirates.
Hello.
Sorry, that is Amira and Mark, and they're going to be talking from Abu Dhabi. And Pierre Samati is from Energy. Where are you joining us from?
Hi, I'm joining from Dubai.
Excellent. And I'm Belén Gallego. I'm joining from Madrid, but here with us today, there are more than 30 countries represented. So please send us a message to all panelists, all attendees in the chat, and let us know where you're joining us from. And I'm not going to delay this any further. I know a lot of you have been wanting to find out more about blockchain, what it means, how it's going to change everything. I'm sure it's not going to happen overnight, but it's for sure a technology that is very disruptive. So Amira, Mark, you're going to be the first and second one talking. So I give you the floor to you. I'm going to stop sharing this screen so that you can share yours and you can start with your presentation. Go ahead and share your screen. And whilst Amira and Mark are sharing their screen, just wanted to give you a reminder. We are recording this webinar, okay? So you can access it afterwards. We are going to send you also the PDFs of the presentations we're seeing on screen. So worry not, they will be sent to you, and you can send questions and answers in the box at the bottom of your toolbar. Anything else that you need, just send us a message, okay? Amira, Mark, it's off to you now.
Hello, everyone, and thank you for making the time to join us from all over the world. My name is Amira, and I work for a talent management entity that is called Agial, and it is owned by Dark Matter. I'm the VP for Education and Scholarship, and our role is to recruit and develop the talent needed to meet the needs of our clients. We focus specifically on the STEM and the security-related fields. As such, my section will be focused on the human capital aspect of the blockchain economy. So I'll try to address and answer three key questions. One, how will the blockchain impact people working in the clean energy? Number two, what are the two types of people who are critical to the success of the blockchain? Number three, the third question, what type of talent is needed to drive the economy-enabled blockchain? So let's go and start with the first question. So there are five main areas that will be impacted and will relate and will impact the professionals working in the energy sector. One is trading, where blockchain enables the prosumers to sell and buy the energy directly with a high degree of autonomy. The second area is finance. The blockchain will help them make payments via cryptocurrency, as you already are familiar with. The third one is data storage. The blockchain can help us keep a distributed, secure record of all energy flows and business activities, with all parties identifying themselves through their digital identities. The fourth area that will be impacted is the legal systems. Blockchain enables smart contracts, which can execute predefined processes of transactions without the involvement of a third party, thus enabling full automation and regulating securely the supply and the payment of energy-related services. The fifth area that will be impacted is asset management. The blockchain can regulate ownership and current state of assets, for example, smart meters, network generation facilities, offering a tamper-proof and transparent way of managing certificates for renewable power and emission allowances. So based on those five areas, Based on those 5 areas, I just want to let you know that the technology behind those disruption will be covered by my colleague, Dr. Mike, after my talk. So now let's move on to the second question that we have on our agenda. What are the 2 types of people that are key to the success of the blockchain? Number 1 is the users. We all know that without a critical mass of people, users who trust and transact using the blockchain can never reach its full potential or maturity. So staying true to the value added by the blockchain to its users can help us expand its base. So our users are looking for 3 key features. 1 is decentralization, 2nd, efficiency, and 3rd is trust. Let me give you an example of how a blockchain will help us help our users with its efficiency. So blockchain can cut costs and speed up the processes by not only cutting the middleman, but also, as we have discussed, through automation, through smart contracts. Let me give you an example. So if a customer fails to make a payment, the smart contract would automatically arrange for the power supply to be suspended until the payment is received, provided that both parties had previously agreed to include such a mechanism in the contract. So from a user perspective, this not only increases productivity, but decreases cost. So that was from a user's perspective. But you know that users cannot receive such added value without the expertise, and it's not possible without experts. At the individual level, we need experts who are able to design, build, maintain, test, and secure the blockchain. And at the organization level, you need expertise to know how to leverage the blockchain technology as a strategic differentiator. However, talent, as you already know, and expertise is very scarce. All 3, the government and the corporation and universities, are all struggling to find talent. And the way to address the human capital challenge is to look at both sides of the formula. 1 is the supply, and the 2nd is the demand perspective. From the supply perspective, what we do at Agial is we're working with high school students and high school graduates, which are the Generation Z, and trying to sponsor their studies and helping them get into the following fields, the fields of study: computer science, electrical, nuclear engineering, and mathematics. That's how we can develop and create a pipeline of graduates who can work with the blockchain technology. We're also helping them get into specific universities. And this is on your screen. You have a list of universities that we are trying to partner with and working with. That's basically the list from US-based university, but we have also included some examples of English-speaking programs that are outside the US. If you are a professional working in the finance, legal, HR, or governance aspects of the clean energy, and you would like to incorporate and integrate the blockchain within your department, definitely the first thing you need to do is to bring in someone, a computer scientist, for example, to your department to set up the blockchain for you. But also, in order to understand how to leverage the blockchain to meet your financial, legal, and HR issues, you can attend postgraduate trainings by one of the universities that we have mentioned earlier. You can also look at different industries like banking, for example, and see what they're doing with blockchain to learn how you can replicate that into your own business. And also, we have mentioned and included on the slides some examples of some conferences that you can attend, such as North American Bitcoin Conference, the London Blockchain Week, Crypto Valley conferences. However, if you are at a management or a high senior leadership position, what we advise you to do is to definitely hire experts into your company. But your key mandate would be to understand, just like any other technology, how can the blockchain solve problems for your client, for example. Or if you were a government entity, how can it add value for your citizens? So how can the blockchain be a key differentiator in the market? What does it mean? How can you use the blockchain to enhance your value proposition if you are leading on a business? So in order to create that mindset as a leader, you can read up and and some of the conferences we have mentioned. You definitely, we also included an example of an executive education program such as the B9 Lab Academy in the UK. That's from a supply perspective. From the demand side, what we are doing is we're partnering with universities to recruit talent. As a business or as an organization, you need to create that collaboration, promote research, fund research within universities. Look for specific talents such as cryptographers, math and physics professors in academia who are interested to migrate in the industry. You need penetration testers, security analysts. The examples that we have on the slide are all needed so that you are able to design and implement a blockchain in a secure and efficient way. So the team you're gathering should include some of those expertise that is on the screen. Another thing that you can do as a business or as an organization, you need to set maybe KPIs and incentivize cross-functional collaboration from an research and development perspective, bringing in the computer scientists and other different entities and departments within the organization to promote innovation. If you are in a position of doing so, we advise you to acquire a startup or partner with a company with a successful track record in the blockchain. In terms of people, just to reiterate, they are at the heart of the blockchain-driven economy, and talent is a catalyst that can propel that blockchain revolution forward. So yes, we are in need of an educated workforce able to understand the technological and the business aspect of the blockchain, but we also need talent that is able to address the social, the ethical and environmental challenges that arise from mining, self-regulation, decentralization, transparency, anonymity, and cybersecurity. So as we adopt and integrate the technology, it is key to look at the blockchain through both lenses, the science and the society. So we need a joined-up approach and knowledge to ensure that the blockchain is an enabler and not a disabler. Dubai, for example, is an excellent case study that has shown how they have mobilized an interdisciplinary team of experts to set up the strategy for the application of blockchain across all its government entities, and they have set and they want to do it by 2020. It is a bold ambition, and we are so excited to be part of this. I now leave the floor to my colleague, Dr. Mike, who will dig deeper into the technology of blockchain and discuss its impact on the energy industry. Thank you.
Okay, hello, I'm Mark. I'm the lead cryptography engineer here at Dark Matter. And my main role is related with research and development of all the cryptographic foundations that could be used by blockchain technologies as well. And blockchain is one of my personal passions. So today I'm going to talk to you about the technology behind blockchain. And specifically, I'm going to focus on the current and also the future impact of it in the energy industry, okay? So to start, here you can see the picture of the Time magazine of Satoshi Nakamoto. Let me start and go back 10 years ago. In 2008, Nakamoto published a paper on a cryptography mailing list where he was describing a Bitcoin digital currency. This paper was titled Bitcoin, a peer-to-peer electronic cash system, and aimed to solve an open problem at that moment where people wanted to use electronic cash, but didn't know or didn't have a proper technology behind it to support it and in order to be able to do it. So in 2008, Nakamoto published this paper. In 2009, they released the first Bitcoin software, and as part of this implementation, they also devised this very first version of a blockchain database. As a kind of curiosity, for those of you that don't know it, nowadays, up to today, we don't know who Satoshi Nakamoto is. Might be one person or might be a group of persons. And if he was a single person, he would be within the wealthiest person in the entire earth. So let me go with an example of how blockchain works. So let's assume that we have persons that want to perform a transaction using digital currency. One of them wants to do a payment to the other one. And then what happens is that within a blockchain, within the blockchain ecosystem, what we would have is this requested transaction would be broadcasted to a peer-to-peer network consisting of computers, which we can also call nodes in the case of blockchain. Then the network of these nodes would validate the transaction, and all these nodes compete to achieve such validation. This is what we call the consensus problem, where all these nodes must agree on a certain decision, even if either if the transaction validates or doesn't validate. In this case, let's assume that the consensus algorithm is one of the most well-known ones, called proof of work, where all nodes compete among each other in order to find a solution to a given problem. Then let's assume also that one of these computers finds the solution and then is able to validate the transaction and to verify that it's correct. The next step is to put all the transactions that have been verified together in the same block, and then to put this block into the blockchain in a permanent and unalterable way. By permanent and unalterable, we mean that we use several cryptographic primitives in order to ensure that the data that is put into this distributed ledger or blockchain cannot be modified. And finally, the transaction is complete. So this is like the overall overflow of a blockchain-based digital currency transaction. It's a very simple example, but that this can be used as the foundation for a lot of other blockchain systems that we have nowadays. So why is the world interested in blockchain and specifically in smart? So basically because as Dr. Amira previously introduced, traditional systems are error prone, are slow, and then require a huge mediation of intermediaries in order to resolve conflicts. And this translates directly into stress, time-consuming problem-solving activities, and then a clear increase of costs. By enabling blockchain-based systems, what we are going to achieve are cheaper costs. For sure, they are going to decrease because they are not going to be intermediaries. Everything is going to be more transparent because the information is going to be out there in the distributed ledger, and anyone with the right authorization to access the ledger will be able to check and verify anything, and it will be more effective as well. In this slide, you can see several examples where the blockchain technology could be applied to smart cities. It ranges from financial services sector to government or identity. For instance, blockchain could be applied as a smart contract in the ownership rights sector, for instance, to protect music artists. Or, for instance, it could also be helpful in order to put our passports or ID cards into a kind of distributed ledger that could be distributed everywhere, and we wouldn't be forced to carry with us always these documents. So anybody that wanted to verify our identity would be able to do so by checking the blockchain. So, but blockchain doesn't come without problems. There are still some issues that we have to solve, and one of them is the impact of the climate. So, as you know, Bitcoin is the most popular cryptocurrency. Most of you know or have seen this in a newspaper or in the news, or know someone that is trading with Bitcoin. Its price has increased massively over the past decade. This has made that Bitcoin miners compete to, this technology forces Bitcoin miners to compete in order to get the next solution of the proof of work, as I said, and get the next reward. And this skyrocketing price of Bitcoin over the last years has attracted more and more miners, which has led to soaring energy consumption just dedicated to Bitcoin mining. Let me share with you some of the numbers to capture this issue. Sorry, please. Okay. 415 kilowatt is the energy that consumes a single Bitcoin transaction. If we extrapolate that to a year, to an entire year, it's 44 terawatt Bitcoin, for Bitcoin's total annual energy consumption. This translates into a 0.20% of the entire world's energy consumption in a year. If also an interesting number is that if Bitcoin was a country, it would rank 54 in energy consumption, just right beside Portugal. If we want to compare Bitcoin with the traditional credit card payment system, or for instance, Visa in this case, with the energy consumed by a single Bitcoin transaction, we would be able to do 200,000 Visa transactions. And also, and to finish, with the yearly energy consumption of Bitcoin, we would be able to power a little bit more than 4 million US households. So these numbers show that we have some kind of a problem with Bitcoin and the impact on the energy industry. There is not a known foreseeable solution for Bitcoin, but there are alternatives for which researchers and engineers of the blockchain ecosystem are working together to put in place. And one of the main areas of interest is the consensus algorithm in this case. So with that, I end my talk.
Thank you very much, Mark. Thank you very much. Okay, we'll have some questions for you, but we'll get to them afterwards. So if you can just stop sharing your screen at the top. And okay. I believe that we have Dr. Said online. So we're just going to unmute you, Dr. Said. Can you mute me? And Dr. Said, can you hear?
Yep.
Sorry about those loops. What the issues, we're in the same room. Anyway, doesn't matter. Dr. Saidi, we're going to share your presentation, okay? Hopefully, we'll get through this. Anthony, can you send the presentation? And if you can go through the presentation, we're going to be able to hear you. We're going to now switch on your
There's a lot of interference.
Dr. Saidi, yeah, there is a lot of echo. If you can just try and see if you can talk. So here's what's happening, because me and Araceli, you're using Araceli's computer, so me and Araceli in the same room. So what I'm going to do is I'm going to switch off my microphone, then I'm going to switch on yours, and if you can start talking, and if we cannot manage to do it, then we'll organize another webinar just for you to talk, okay? So let's try one more time, and hopefully this time it will work. So now I'm going to switch off my microphone, and you switch one on.
Hello? Good. There's a lot of, I'm sorry,
So I'm sorry, I'm afraid it's not worked, so we're going to have to find a way around that. So Rafael, if you can just, Pierre, we tried, we hoped that it would work, but as we weren't expecting this and nothing happened in the trials, then you go for it, you give us your presentation, go right ahead. and then we may have another go. Go for it, Pierre.
All right, let me just share my screen.
Just to let you know, we are recording the session. We are sending you the materials. Don't worry about making notes. All right, go for it.
All right. Okay, yeah, thanks everyone for joining. My name is Pierre. I'm the CEO of Energy International, a company based in Dubai, and we are focusing on consulting and venture investments, and we have been involved in the blockchain space for quite some time now. The few slides I prepared, and hopefully we have a good discussion afterwards, are actually about specific applications of blockchain in the energy industry, so pilots that we're already doing live today. And the way forward toward the machine-to-machine economy, because we believe that is ultimately the main enabler of blockchain. So, as you heard, and as you're probably all aware, and I think the subscribers for the webinar speak for themselves, blockchain is a super hype topic at the moment. Everyone knows about Bitcoin, everyone knows about blockchain, but it's hard for most of the people to grasp really what is the benefit of it. So the only message I want to give to you, and I would really like you to get away with it, is that a lot of people will try to tell you about amazing ideas about blockchain, so they can blockchainize everything, but you really have to be a critical thinker to understand what's real and what's fake. And I think with the excellent presentation that Mark just gave about how the blockchain works, you should be able to always ask yourself the question, is this really an application where we need the blockchain, or could that be done far more efficient in a normal decentralized database way? Looking at blockchain where we are right now, this is the Gartner hype cycle. So it actually tells you a typical pattern of technology and how it's going to be hyped among the community and the public, and then how it crashes immediately afterwards in terms of visibility. And it's hard always to tell where we are with blockchain, but from my point of view, we are very close to the peak. So examples that you've seen in the past where people were just adding blockchain to their company name and immediately their share price rose up clearly gives you indications that we're close to the peak. So to continue with where Mark left off with the proof of work energy intensive consensus algorithm. So to repeat that, the consensus algorithm is the core of the blockchain technology to achieve basically an anonymous decision among the participants. As you heard, proof of work, very energy intensive, but there are already other consensus algorithms that, for instance, we use in our projects. And it's important for you to understand that there are roughly like 3 different approaches, because most likely the 2 that I'm going to explain to you are the ones that will apply to your project. One is proof of stake, where instead of using huge amount of computing power, you, if you want to participate in validation of the blockchain, you put in a kind of a commission to, like, if you want to say so, like an escrow account. So you put your stake in order to make the proof of the blockchain. If you tamper with it and you get caught, your stake is going to be taken. So you would actually lose what you put in. And that is very energy and cost efficient because you don't need large computing power for that. The third consensus algorithm that we believe will be the dominant one for any application in the energy industry, if it's not a super decentralized one, and in particular for governments in the Arab world, is proof of authority, which means you predefined upfront who is going to participate in your network and who is going to be allowed to actually achieve consensus. Also very energy and cost efficient. However, it's already a bit away from the traditional idea of a blockchain being a very decentral libertarian idea. It's a controlled environment. Now, we're doing 4 specific things at the moment in blockchain when it comes to energy. And I'm going to go in detail on all 4 of these. The first one is we're using blockchain for peer-to-peer EV charging. The second is we testing blockchain for decentral financing of renewable energy projects. The third one is we have a test community running with a microgrid that is actually trading energy among each other with the blockchain. And the fourth application is the tokenization of assets. Now, what does it mean? To go to the first example, peer-to-peer EV charging, that is live already today. We have in Germany 1,300 charging stations already equipped with a system that basically allows you to rent out your personal EV charger. So if you think about the future, and we might all drive electric vehicles, maybe not, but we will for sure have an increased amount. You buy your EV charging station at home, it will not be occupied when you're away. So what this application allows you is to program that either your friends that you know or anyone can charge at your charging station at a price that you set. And as soon as they charge, you will immediately via the blockchain get the credits for that. And in this case, it's actually back to a national currency. So we're doing that with euros at the moment. At the current moment, there is a pilot going on where a car is driving from Oslo to Rome, so really across Europe, electric vehicle, only charging at charging stations that will allow blockchain payments. And coming back to, for instance, the United Arab Emirates on this, I think this is a key solution for inter-Emirates EV charging. Second pilot which we're doing, we are currently setting up a crowdfunding platform that will allow micro investments into renewable energy. What that basically means is anyone can participate with cryptocurrency, no matter how small or how big the amount is, to fund renewable energy projects. And on the other side, through a secured way of measuring the output that is immediate of the PV plant, that is again feeding back into the blockchain, you will get a guaranteed return based on the production. The benefit of that is that you have far more trust to invest in renewable energy projects in a country far, far away from you and with people that you normally don't know, because you can trust in the technology. The third example is the community energy exchange. What you can do with blockchain is you can create a microgrid among communities, and you can allow the community to automatically trade energy depending on the needs of the participants, also for a set price. So for instance, if one of the participants has a surplus energy because he has so much rooftop PV on his roof, he can sell the surplus energy to his neighbor that might be in need for that. The fourth example is the tokenization of assets. Tokenization of assets means we are creating a digital twin of an energy asset on the blockchain. And then by, again, securing smart meter data going to that blockchain, that we can automatically create a token, for instance, for every kilowatt hour that is produced. You also already have today other examples like SolarCoin. Probably most of you heard that they signed up with Aqua, I think 2 weeks ago, which is a similar example of this. So, however, blockchain is nice, but what we really think will drive a fundamental change is the fusion of technologies. Fusion of technologies for the fourth industrial revolutions, meaning the benefits of blockchain, advancements in the whole Internet of Things economy, advancements in cybersecurity, and artificial intelligence. So when all these four technologies come together, then from our point of view, a revolution is going to happen. So blockchain is great. We really love the technology, but on its own, it will only achieve so much. So you really need other technologies to feed into that. And what this will enable is something we call the machine-to-machine economy. What that means is that we see a future where we have an increasing amount of machines talking to each other, using blockchain to also do transactions. And what that means for society is we will have a fundamental shift, because in the world today, you have a very easy to understand world. You have customers and you have companies. In the future, you will have a third participant. You will have customers, will have companies, and you will have machines, which means for companies, and that's what we're investing in already today, is as a company, you need to understand that a machine in the future can be your customer. and it can be an energy asset or any street furniture, basically. Now, I would like to close the presentation with two examples that give you a bit of like a wild idea on what that could mean in the future. So if you think about the combination of a cryptocurrency with, for instance, a technology or platform like Uber and autonomous driving vehicles, what will come out is a self-owning car, which means a car that drives you to work every morning. And once it drops you off work, it will work on its own and even create its own money. So it can drive around, pick people up, buy its own electricity, buy its own insurance, and really take care for itself. Now, if you translate this concept to the energy industry, what you see is that if you combine cryptocurrency with smart contracts and artificial intelligence, we could potentially see a self-owning PV plant. So a PV plant that makes its own commercial decisions on when to sell, when not to sell. A PV plant that makes its own commercial decisions on when maintenance is needed, depending on the market. And I believe that is really one of the major steps towards a fully industrialized machine economy in the energy sector. That's my last slide, and then let's go into discussion.
Thank you very much, Pierre. Very interesting, and a lot of the questions have gone about, what does it mean for energy? So I think you answered some of those questions. But let's start with the issue that comes up over and over again, and at least I've seen it mentioned in 5 different questions, but in different ways. The issue of energy consumption. We've all read the headlines. Oh, Bitcoin consumes so much energy. We're wasting away our planet by having Bitcoins. Honestly, when I read those articles, I felt like the people who were crunching those numbers had no idea about energy whatsoever. But I don't know, maybe from you as an energy man, and Mark, you can give us also your opinion on, is this as big as they say? Is it an issue? Do we have to worry? Go for it, you guys. I don't know who wants to take it first.
Okay, then. You want to go first, Mark?
No, you can go.
Okay. So one thing that people, I think really, these guys who write these articles, they don't understand, or I think it's a bit of an unfair comparison. If you look at the energy consumption of Bitcoin on its own, then it's high if you look at it. You need to compare it to what Bitcoin initially wants to be. Bitcoin has the plan to replace the whole monetary system in the world. So then you also need to compare like apples with apples and not apples with pears in this case. However, I completely agree that proof of work and Bitcoin will most likely, if there's not a fundamental change, it might go away in the next 10 years because it's just not an efficient mechanism. And that ties maybe into one of the other questions I just saw about the other cryptocurrencies. We have other cryptocurrencies like Ethereum and I mean, if you look at CoinMarketCap, they're like, I don't know, 1,000 in the meantime.
Yeah, but I'm sorry, there is like 1 million of them. We don't even know the name or Dogecoin, Bitcoin, Bitcash coin.
Exactly. So I think what is important, maybe also for the audience to understand, that you to simplify it, you can think of it like different generations of blockchain. However, I'm not saying one is better than the other, but Bitcoin was the first generation. It had a very single purpose. Then you had Ethereum as a kind of second generation blockchain that introduced the use of smart contracts to the blockchain. So another application. And then we already today have like a lot of contenders for third generation blockchain, like IOTA, like EOS, but things, cryptocurrencies that are not proven yet.
Someone is saying, but why? Oh my God, why so much energy? How many computers do you have on? Maybe Mark can answer that one.
Yeah, basically the amount of transactions that, of computations that you need to do, it's huge, and it's somehow the difficulty of the proof of work, it's somehow adjusted. But for instance, several Bitcoin alternatives that have forked from this original version of Bitcoin, they are called, I mean, you can find them as Bitcoin Cash or Bitcoin Gold. They share the same core idea than Bitcoin, but they have a more, I would say, efficient algorithm because they are able to adjust the difficulty level that it's still sustainable, and I would say it makes sense to still mine that cryptocurrency. So, I mean, there are alternatives to that, but the current blockchain one, it has attracted so many miners on it, and it's consuming so much energy that the numbers just speak by themselves, I guess.
And this is a question for Pierre. Pierre, really, is blockchain the solution to all our problems? Is it better than what we have now, really, in renewable energy? This is specific to renewable energy.
I mean, if the question is that general, the answer is no. I mean, as you saw, blockchain solves issues or makes processes more efficient where we today have a middleman. So, for instance, in markets where you already have a very liberal energy market system, you could think of potentially a future where there is no energy company in the future. Then it's for actually the audience to answer if they think that's a good idea or not.
Decentralization, total decentralization. What about the issue of cybersecurity, security, regulation? You know, politics, they love to take away things and to protect their own businesses. So how easy is it going to be, you know? I don't know, Pierre, you start, then Mark, you can also answer.
So what's the question on how the regulation will come in place? Or?
Yeah, I mean, the question is of all these things that the third party kind of like supplies, which could be the security, you know, in this case, cyber security, and the regulation or protection side of things, you know, where, you know, I don't know how many accounts have been hacked from the past week, where a lot of, I don't know whether it was Bitcoin, but blockchain or cryptocurrencies were stolen. So, you know, and there, once you lose it, you lose it. You know, there can't be any insurance. So the question of those little things that we're very used to, how are we going to, how does it work, blockchain?
Okay, so yeah, I think from a security point of view, that's also one of the points I mentioned in what we believe is the fusion of technologies. There needs to be for sure huge advancements in cybersecurity. However, I think what is also important to point out that the Bitcoin blockchain itself, like the technology of blockchain itself, has not been hacked. And it currently, if you look at the market cap, it has a $200 million price tag on it. So it's a huge target for hackers, and so far they haven't been able to hack it. All the hacks that you read about are either from very immature different versions of other blockchains, or it's actually hacks of the exchanges. And that has nothing to do with the blockchain. It's just that if you think about your online broker account would actually be hacked. It has nothing to do with the shares that you bought, but actually with the security of the exchange.
Exactly. And to add a comment on that, there are, I mean, when we speak about security in the blockchain, there are several proposals as Bitcoin that were proposed initially that maybe are very robust, but were not designed with security into consideration. But as this technology advances, as Pierre mentioned in his presentation, now we have several blockchain proposals, for instance, Monero or Zcash, which are extremely focused on security. For instance, providing 100% attestable anonymity in this distributed ledger. So, I mean, my view is that in the coming years, it's going to be very important to have a wide vision of how cryptography and blockchain work together, and they have to be blended, because otherwise, yeah, we have seen several cases of very immature white papers proposing blockchain that have been broken in just a few days. So.
And every time we talk about blockchain, we always really end up talking about cryptocurrencies, probably because it's easier to understand them. But the question is really like, does it mean talking about blockchain in the energy area? Does that mean talking about cryptocurrencies applied to energy, or is there any other uses that we can make out of blockchain that have nothing to do with payments?
what you want to have in every blockchain transaction is still a kind of token, which is a kind of currency, if you want to say so, to prevent the network from being spammed. So otherwise, if everything would be free, you have the issue that people might abuse it and spam the network. So, and that's why most of the blockchain technologies also in the energy industry use a token to prevent that. I think, I mean, if you ask about one particular use case that is without any cryptocurrency on the blockchain, I think putting documents on the blockchain is one of the easiest. However, it also doesn't mean you really copy the document on the blockchain, but it means you put the digital fingerprint that every document has on the blockchain. So at the later stage, you can actually then check if that digital fingerprint on the blockchain matches the document. And that doesn't need any cryptocurrency.
Do you wanted to add anything, Mark, or are you happy with that? Because I know you're working with insurance a lot.
No, from what Pierre said, I think it's a great example already. I mean, you need some kind of token in your blockchain, and you can use blockchain as a distributed database in the very extreme case, because that's like one of the most direct use cases as well.
Okay, so how does that currently, anything that's got to do with, you know, cryptocurrencies or blockchain, deal with security commissions, you know, being allowed to do things like crowdfunding? So how does this kind of interact these days into the financial structures that we already know and love? I don't know if love is the, you know, the word here, but essentially the existing structures.
Yeah, I think you always need to, when you do these kind of projects where you use cryptocurrency to finance something in a country, you need to work very closely with regulation. Otherwise, there is no point on even trying it, because for sure regulators want to be involved. So this is unfortunately not a question I can generally answer, but the main point is you need to comply to regulations, which so far has been very positive. So.
There is a question here about exactly how the solar crowdfunding project works with Dubai Carbon.
Sorry, which one?
It says, can you please share how exactly your solar crowdfunding project with Dubai Carbon utilizes the blockchain?
What we're doing is we're basically tokenizing again the assets, so the asset project, so the PV plant, let's say in Africa. We ensure that the production of that PV plant is proved and audit ready. So the blockchain will ultimately record how much kilowatt hours that particular asset is going to produce, and then according to that, you have contracts on how to distribute back the money that the PV plant actually earned. It works very similar to like a normal project. It's just that with blockchain, we have the opportunity to like break it down and democratize it to make it to actually enable micropayments.
And here is a question about the topic of efficiency. Which is the most efficient blockchain, or which of the blockchains publicly available, one that I could use for my own smart contract applications, would be more efficient in terms of security, energy, process efficiency?
I would say it always depends. I mean, what do you mean with efficiency? So there's like numbers of transactions that you can do per second, which is one indicator. There's an indicator of energy usage. And there is and for sure there should be an indicator of how secure is the system. And if you would go with your own energy or blockchain project, I would really recommend going with one of the proven technologies. And that at the moment, from my point of view, is Ethereum or Hyperledger. Mark, I'm pretty sure you have an opinion on this as well.
Yeah, I would say that depending on what you mean about efficiency, but Ethereum, it's like a pretty decent blockchain technology. There are other, I would say, alternatives to Ethereum that like are newer and maybe have been designed with efficiency also in mind. But at the end, it depends on what performance requirements do you have, or what energy consumption requirements you have.
Okay, so two extra questions that have come a few times. One is the threat to jobs. You know, this fourth industrial revolution, how much is of a threat to jobs? I know this is Moramira's, she's still there, yay, excellent. So I know we always have to be positive, right? The future's, you know, got a lot of opportunities, but, you know, there is certainly a question about how people interact with these new technologies. So do you see blockchain as a threat to job opportunities?
Yeah, based on the research and based on what we've been reading in terms of the effect of automation, there are some jobs that are going to be to disappear, but there are new jobs, just like one of the participants have mentioned. Many jobs are going to be created, specifically the jobs that have to do with problem solving, emotional intelligence, ethical issues, or creativity and innovation that cannot be done by AI or by machines. The jobs that do not have right or wrong answers, the jobs that relate to servicing or delivering consulting services to others. So it's there will be transformation in the types of jobs that will be available in the future, but that's not no threat to. I don't see, based on what I have read and based on what we've seen in terms of automation in the past, I don't see any threat in terms of human work.
So another follow-on question for you, Amira. So how me as a person working in the energy sector from a company that could be anywhere in the supply chain, how do I benefit from this new technology? How can I go ahead and, you know, benefit from it? Because it's a very abstract thing, right?
Of course. Remember at the beginning of the section that we have presented, if you were a fresh graduate from high school, so you can actually go in and study at the specific universities that we have mentioned in specific fields, so that you are able either to design, set up, build, monitor, evaluate, and test, and even secure a blockchain. But if you are now, I'm looking at you as a professional with many years of experience, you would like to use it, for example, for your webinar, the blockchain for your webinar, or blockchain for any industry, attend conferences and attend some trainings, provide postgraduate courses from some of those universities. Look at the finance, because the finance and the banking industry has been making strides in this area. Look at what they're doing and how can you adapt that to the clean energy or to your own business. But make sure you do it with working with computer scientists or people with cryptography background, so with the experts. So together you can come up with a way you can leverage the blockchain, just like we've leveraged the internet. Just look at it as a tool or as any technology that you can repurpose to meet issues that you are facing in your own business. It's just a mindset, but it's disruptive, and it will do just like what the internet has done in the past.
So I suppose one of the things that we have to do is go step by step, but not be completely out of the loop for 5 years and then realize that the whole thing changed.
Correct. And start with a challenge. What is the challenge you're facing right now? And then look at what the blockchain can do to address that challenge. Look at it as a solution provider.
So, question for Pierre. You've had a few questions saying, please explain what is tokenizing, because it is kind of a weird word. I understand what it is, but please explain it so that people understand. Tokenization of an asset. What do you mean by that?
Okay, so tokenization basically means, in the case of energy, you define a certain value. For the easiest example, kilowatt hours. If you say, for every kilowatt hour green energy we produce, we tokenize that and we create, let's say, one solar coin. That means tokenization. So you take a real life, basically something that happens in the real world, and take this as a prerequisite and a hard-coded rule to create a digital coin out of it.
So I suppose it's like Facebook. You're a real person, but then you have a Facebook profile. So this is like assets having a profile in blockchain.
Yeah, however, it's more about an output. So in your example, that would be a digital twin.
Okay.
But the digital twin is then basically the prerequisite for tokenizing energy.
Okay, gotcha. So it's actually the money of the output that you put out. And on that line, there's been a bunch of questions as well about solar coin. What is solar coin? Why do Aqua care about solar coin? What is happening with solar coin? So maybe the two of you could understand, because this is not really a normal Bitcoin type asset. It's an asset that you mint, but you also can earn. So you guys can explain this. I know a little bit about it as well because I went into the presentations, but you probably know more. So Pierre, Mark?
Mm-hmm. All right. Yeah, so, I mean, just maybe a disclaimer up front, I'm not invested in SolarCoin or anything. And we also currently have no relationship with SolarCoin as Innogy. So from my understanding, SolarCoin is exactly doing the tokenization of kilowatt hours, or in this case, I think megawatt hours. So I think for every megawatt hour, you get one SolarCoin. I saw a couple of questions on the chat, which I also answered, like, what's the value of it? Why would you do it? From my understanding, at this point in time, it's pure speculation. So you get something in addition to your already like produced megawatt hours. So you sell your megawatt hours for US dollars or dirhams or whatever the currency of your country is. And then in addition, you can sign up for SolarCoin, and then you get an additional reward, namely solar coins for every megawatt hour you produce. Now, what is it that you can do with it? That really depends on the market. Because you depend on people being ready to accept it as an exchange of value. Why would people accept it? Because they would actually assume that the price will go up in the future. SolarCoin today is traded already on a few exchanges, and it has a US dollar counter value. And I think that's what people are looking at.
It's around $2 at the moment.
Yeah.
But I was in the presentation with Aqua, and they figured that if it got to $25, then energy would be free, so to speak. So there is an actual impact. The point is to create a solar community that would use that as a way to, not really subsidize, but like get solar to be more interesting from the financial perspective across nations, essentially. So it doesn't matter whether your government supports it, because just the solar coin value may be enough for you to guarantee doing that specific project, say, for example, in an off-grid place in Africa. Just the value of solar coin would be enough to pay for that. So that is a little bit the point of it, but it's complicated to wrap your head around it because it's a different way to think about it. It's a bit like carbon credits.
Yeah, a bit like that. So maybe one important point to point out for any cryptocurrency that is not specifically tied to a national currency, so that is not tied to a US dollar or to a euro or whatever. Every value of cryptocurrency at the end is based on speculation. So it's based on us as a community agreeing on a value, because there is no fundamental value behind it. I mean, that's the whole idea of crypto. And I think that's important for everyone to understand.
Excellent. Well, thank you very much. Thank you, Pierre, very much. Mark, Amira, I know she's still there as well. Hi, Amira. Thank you very much for your time. It's a shame that we haven't been able to hear from Dr. Saidi. He had technical problems this morning, but it's okay. We're going to actually film him on his own, so we're going to have a small session with it, and we'll send you also the link. So worry not, you will hear from him as well. This is just the beginning, right? Blockchain is an issue that is going to require a lot of time for us to really see how it evolves. So I'm very sure that we will have another event very soon to keep on discussing these issues. So hopefully we'll have you here online again, Mark and Amira and Pierre. And just thank you to you, thank you to the guys attending as well. And one more thing, thank you to the Clean Energy Business Council, who are co-organizers of this event, and really appreciate putting this together. And without further ado, we will see you in the next online session. Thank you very much.
All right. Bye-bye.
Thank you.
Bye.